In this video, you'll learn the core components needed to support building agents. The first piece, the toolkit, is the agent development kit. This is our open source, code-first toolkit designed to help you build, evaluate, and deploy AI agents. It gives you the fundamental pieces, the building blocks, in either Python or Java, and allowing you to really just focus on the agent's logic. Next, to address the protocols challenge, we have the Model Context Protocol, or MCP. This is an open protocol that standardizes how your applications provide context to LLMs. Imagine your agent needing information from a database or a web service. MCP provides a uniform way for that context to flow, making integrations far more predictable and less error-prone. And then, to tackle the agent platform challenge, we bring Vertex AI Agent Engine. This is Google Cloud's managed platform specifically designed to deploy, manage, scale agents in production. And this takes all the heavy lifting off of your shoulders when it comes to infrastructure, security, and scalability. This is critical for enterprise applications. And finally, completing our agentic flow, we have A2A, which is our protocol, and as the name implies, it is an open standard designed to enable seamless communication and collaboration between AI agents. This opens up entirely new possibilities for complex workflows where multiple specialized agents can work together to achieve a larger goal. And the ADK supports creating agent cards for A2A, so then you can publish your agents after they are created. This full stack, ADK, MCP, and Vertex AI Agent Engine, along with A2A, provides a comprehensive, robust, and developer-friendly approach to building the next generation of AI agents. Now that we've introduced ADK, let's talk about some of the powerful features. You can orchestrate actions across multiple agents and tools, seamlessly blend deterministic code with generative AI reasoning for hybrid approaches for creative solutions that you can control. The ADK includes an intuitive local UI, which enables rapid development, testing, and tracing agent actions visually. And it sounds like these are tools that developers do definitely value. And so in order to support these capabilities, like long-running asynchronous tools, human-in-the-loop, workflows, and any generative model, optimized with Gemini as the default, you can also call remote agents and leverage thousands of existing tools with MCP support. And so to answer the next question, why ADK? There are many frameworks. Why would we choose this one? Well, first would be flexible orchestration. Whether you're using predefined workflows or need more adaptive LLM-driven use cases or support for them, multi-agent architecture for creating scalable applications with multiple specialized agents in a hierarchical structure to complete complex tasks. The rich tool ecosystem to integrate pre-built tools, custom functions, and third-party libraries like LangChain, or even other agents to expand your agent's capabilities. The ADK is deployment ready, so you can containerize and deploy agents from your local machine, scale with Vertex AI Agent Engine, or use your own infrastructure if you're more familiar with Cloud Run or Docker. We've also got the built-in evaluation piece, where agent evals are naturally critical to supporting the agent workflow, and ADK allows you to assess agent performance by evaluating both the final response and the step-by-step execution against your predefined test cases. And lastly, building safe and secure agents. Implementing security and safety best practices into your agent's design is powerful and helps build trustworthy agents. So let's talk about how ADK supports from a code standpoint. Defining these agents is pretty straightforward. The ADK minimizes the boilerplate code that you'll need and lets you focus more on the logic. You can easily specify the model instructions, the goal, the available tools, and define hierarchical relationships between agents for those complex tasks. Like having a supervisor agent that can delegate a workload to a specialized child agent for flights and hotels. In this case, we have a route travel agent with sub-agents defined under the tools, including a flight agent, and as you can see, the flight agent itself also has its own set of tools that it can access. And so we've covered tools. As we mentioned in the previous code's example, we have the option to create agents and define them as tools for other agents to use. ADK supports other built-in tools as well, like Google Search, LangChain. If you already are working with another framework, it is very easy to bring that into our framework here. We've got open API integration, and the ADK, one benefit that I like to just call out quickly, helps you both use and consume MCP tools in your agents. So whether you're building a tool to call on an MCP service or exposing an MCP server for other developers or agents to interact with your tools. Tools work with the functionality that LLMs can decide when and how to use them, and they do that based on your instructions and tools description. Let's quickly talk about the code-first nature of the SDK and the flexibility that it allows you to build. So you can build interactive chat agents with low latency responses, background processing agents for monitoring systems or handling things like offline tasks, and even real-time agents. Those agents can interact naturally by using voice, video, and this is because native bidirectional audio and video streaming is natively supported in the ADK, and that supports the live interactions with agents. Let's talk about having a managed runtime. So Vertex AI Agent Engine, this is sort of the developer journey that is visualized when deploying with Agent Engine. So once you've defined your agent, using our ADK or another open source framework like a LangGraph or a Crew AI, you can use Agent Engine SDK to deploy your agent to production using only a few lines of code. This provisions a fully managed runtime that gives you CRUD APIs that you can invoke and manage, and your agents can be all managed programmatically. It's built for enterprise governance, offering security features like VPSC and authentication, and through OpenTelemetry, Agent Engine is integrated with Google Cloud's observability suite, so that enables cloud logging, monitoring, tracing, so you can observe and understand your agent behavior over time. You can also invoke an agent from any client, like your own application or website, and you can register your agent in Agent Space for employees within your organization to discover and use agents to get work done. The TLDR on our journey to production with ADK. First, you're going to start by developing that agent with the ADK, or you can add an ADK agent with MCP. You will deploy to a fully provisioned runtime, which will manage context. That includes sessions, memory, examples, measure and improve quality with the example store, and then observe agent behavior with Google Cloud Trace, logging, and monitoring. All of that can be done using Agent Engine. And then you also have the option to then connect those agents via A to A. And this is how we see our journey from start to finish. All right, you can scan the QR code to test sample ADK agents. And if you'd like to learn more, you can join our longer webinar session with the link that's in the description. And we've also got our startup technical guide on AI agents here to support you along the way. And we hope that this enables your journey and makes it a much easier experience. Thank you.